What up, guys? Third video for today. So I wanted to take a second and walk you guys through what you need to do for the Newton's second law lab. I'm actually going to go through each part of it and pretty much give you all the answers if you watch the whole video. So this will be here for you guys, probably right underneath the Newton's third law or second law assignment. All right, so let's get right into it. Let me share my screen. We'll go to the January 8th assignments. You can see this stuff isn't published yet on Schoology. Well, actually, by the time that you watch this video, it will be published on Schoology. But we have the intro video, the video solutions to the work that you did. I know that that doesn't look like the work. That was just a thumbnail that I had. But we're going to be working on the Newton's second law simulation lab. So I'm going to open that up real quick. I have it as a Word document and as a Google document. If you guys want to work with a partner or something like that, feel free. Groups of 2 or 3 or something like that, if you'd like to work with somebody. So I'm going to open this up. I don't know why it has, I must have put in something in there that it doesn't like. But you open this up, right? It's got a link. You guys will obviously not be able to edit this one. I didn't give you editing permissions for this one, so you'll have to make a copy for yourself. So file, make a copy. Okay, so we'll open up copy of Newton's second law lab here. And our objective for today, right, we're going to use the simulation to discover the relationship mentioned in Newton's second law of motion. Newton's second law states that there's a relationship between force and the resulting acceleration of that object. So we want to try and dig in deeper to that relationship and see what we can come up with there. So what you're going to need is Excel or Google Sheets. I don't really care which one you use. I'm going to go through this in Google Sheets because I'm assuming that's what more of you guys are going to use. And then the PhET simulation website. So this is a link to that website. There's actually 3 links on the page. There's the PhET simulation link at the top. There's a link right here on the website. And there's also a link right there. So either one, all 3 of those will take you to the same place. So I'm going to open that up real quick. And this is what you should see, right? It should open up to forces and motion basics. So let's go back here. And the next step is the procedure, right? So there's 8 steps as you go through with pictures kind of describing each step that you might need. So I'm going to go through and walk you guys through the procedure. So follow the link, which I did already. It's up at the top. You should come to a screen that looks like this, right? I have a little picture there. Click the 4th lab option, acceleration. So I'm going to go over here and open up the acceleration lab, the 4th one there. Should take you to a screen that looks like this. On the right-hand side of the screen, we need to check some boxes, right? Make sure that the masses, values, and acceleration boxes are all checked and slide the friction bar all the way to the left to none. So I'm going to go here and on the right side, right, check values, masses, acceleration, and then slide the friction bar all the way to the left. It will turn the track to ice, right? You can see the acceleration value popped up there. The mass values popped up with each of the masses down at the bottom there. So that's good. We don't need speed or the sum of forces. So don't worry about those 2 guys right there. Oops, wrong one. All right. If your screen looks like this, you nailed it. So you can see all the things right there, right? Just double check that mine looks exact values, masses, acceleration, friction, slide all the way to the side. Good. That is what mine look like. So next we need to choose an amount of mass for our stick person to push. You can choose up to 3 objects. You can choose whatever you like. You don't have to choose 3. You can choose 2. You can choose 1. So I'm going to come over here and choose a couple of objects. I'm going to choose the water and a crate. All right. Water and a crate. Write your total mass here. So the water was 100. Crate is 50, so 150 kilograms right there. So I'm going to write in 150 kilograms. So total mass that I chose was 150. you can see in this picture here, we would have to add 250 and 40. That would be 290. So if I was using this grouping of masses, we would have 290. Okay, so now we're into the data collection. All right, so we're going to start collecting some data here. Keeping the mass value constant, vary the amount of force using the slider at the bottom, and make a note of the acceleration it causes for your mass. So we can change force down at the bottom using this slider or the arrows, and then we can see the acceleration it causes at the top here. So I like using the arrows because it makes it stay at the value you choose. If you try to use the slider, it actually doesn't stay where you want it to stay. It drops back to 0 when you let go. So if you use the arrows, you can actually get it to stay on a certain amount of force, right? Maybe the double arrows go by 50s, the single arrows go by 1s. So you can choose whatever values for force that you want. And you can see here, I get an acceleration that goes along with that force. So when I have 155 newtons applied, I get an acceleration of 1.03 meters per second squared. All right. So that's what we're going to do to collect data. But we need to put them into a data table. So I'm going to open up a Google Sheet. Make a new one. We'll call it Newton's second law. Second law data table graph, because the graph will go in here as well. All right, so I can see how I set up the data table here. Acceleration on the left, force on the right. So acceleration measured in meters per second squared. It doesn't like, how do I do, can I do superscripts? No, that's strike through. I thought I could. Maybe I can't. Meters per second, caret 2. Means the same thing. All right, meters per second squared, and force measured in newtons. We haven't talked about force measured in newtons yet, but that is the measurement value for force. So I'm going to slide this over so the whole acceleration fits. And there is my data table. I have a spot to put acceleration. I have a spot to put force. So let's, pause this. Let's make it stop. You can make it stop by pressing the reset button. But if you press the reset button, it takes away all your values and everything. So there's that. All right, so I'm going to choose values now for force and then write down the acceleration that it causes. So I'm going to use just the big slider. So first one is 50 newtons. When I apply 50 newtons, I get an acceleration of 0.33. So I'm going to go over here, acceleration of 0.33 with a force of 50 newtons. All right, and I think I have 10 trials. Yeah, 10 data points is good. So we're going to do 10 of those. So 50, 100 is 0.67. Oops. 0.67 for 100. We do 150, we get 1. Oops, I forgot the 0. 150. If we do 200, we get 1.33. 1.33 for 100 or 200. If we do 250, we get 1.67. 1.67 for 250. For 300, we get 2. 2 for 300. You got to be careful because if he gets going too fast, the simulation, oh, he fell down. Stop. Reset. Oh man, I had to reset all the way. Slide the friction all the way to 0. All right, so I got going too fast, so I had to reset it. What was I looking at? I was looking at 300. So let's go 350. You can actually pause it if you don't want him to like keep going too fast and mess it up for you. Oh, it reset. What was I using? I was using the box and the water, I think, right? All right, 2.33 for 350. 400. I'll press play. 400 is 2.67. 400. 450. Press play. Moves to 3. So 3 for 450. And 500 will give us, oh, he fell off again. Actually, negative 500 will give us the same value, just the wrong way. But I'm going to use him to make it stop real quick. All right, he's slowing it down. He's slowing it down. He's slowing it down. And quick switch to positive 500. 3.33. All right, so 3.33 for 500. Does that give me 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, it gives me 10. So I have 10 data points there. Okay. So 10 data points is good. I got my 10 data points. Using Excel or Google Sheets, make a graph of your data. Force should be on the x-axis. Acceleration should be on the y-axis. So let's go through how to make a graph again really quick, right? Because I know that's something that we probably haven't done in a while. So let's make sure we remember how to do that. To make a graph, we are going to highlight the numbers, right? Just the numbers. Insert a chart. All right, here is my chart. I do want a scatter chart, so make sure your chart type is scatter chart. We want a scatter chart. I'm gonna make sure really quick that am I zoomed in or something? Why can't I see anything? I am zoomed in. Okay, there we go. Okay, so I have my chart here. Let's make sure that force is on the y-axis. So the y-axis goes up to 500. Force also goes up to 500. So force is on the y-axis. That's good. If you set up the data table like I set it up here, your force should automatically go to the y-axis. All right, so that's that. It also gave me a proper title at the top. It labeled it correctly for me, so that's all good as far as the X and Y axes. If for some reason it doesn't label your axes correctly, you can double click on those and change the values. And you can also double click the title at the top and change the value there as well. So if you double click any of those things, it'll let you change what it is. But mine says force versus acceleration, which is what I want. Force is on the y-axis, acceleration is on the x-axis. So I have everything there. We're not finished yet though, because I also need a trend line and an equation. So how do we get the trend line and the equation? We're gonna click on these 3 little dots, open up the chart editor again. And the trend line you find in the Customize tab. So I'm going to click on Customize, and then the 1, 2, 3, third one down here is Series. So I'm going to click the Series drop down and scroll down until I get to these 3 checkboxes. All right, and then I'm going to check Trend Line. That'll give me the trend line on my graph that I was looking for. All right, it looks like linear is correct, so I'm going to keep it as linear. And then the last thing we want to change is the label. Right now, the label says none. We want to change that to use equation. All right, and then use equation, my equation pops up. There it is. I have my equation. So that's all that I need for my graph. All right, so I have created my graph. We highlight the data, insert, chart, make sure it's a scatter chart, make sure our axis titles are correct, and then we go to customize or edit chart, customize, series, and then insert the trend line. Okay, so I got my data table, I got my graph. Let's go back here. Repeat steps 4 through 7 with a different mask. So I do want you to go through and do this twice. I did it once for you. You could pretty much use mine as one of yours, but I went through, I did it once. I want you guys to do it again so that you end up with 2 data tables and 2 scatter plots. All right, and then you're going to copy and paste your data table and your scatter plot there. So let's do that really quick. I'm gonna go over here. I like using the snipping tool to do this kind of stuff. So I have snipping tool at the bottom. If you don't have snipping tool, you can go over here and search for the snipping tool and it should show up right there. But I'm gonna use the snipping tool and snip my data table right here. And then go back to my thing here and paste it in, shrink it down a little bit because I don't need it that big. All right, so there's my data table. Copy and paste your graph. So I'm going to go back and do the same thing. Snipping tool, new snip, cut my graph here. I don't know if the snipping tool, the snipping tool probably doesn't show up when I'm actually trying to take the snip. I don't know if it does. I haven't watched the videos back. But there I have my graph, so I'll paste that in. Go back over here. Paste my graph in. There's my graph. I shrink that down a little bit. All right, so I have my data table and my graph. You guys will have another data table and another graph as well, but that's what I'm looking for. Copy of your data table, copy of your graph. Everything should be included there. Okay, describe the relationship that you see between force and acceleration, right? Just a little description, right? And I've got some suggestions here. Is it positive or negative? Is it linear or curved? So if we look at that, it's definitely linear. It's definitely positive. So we have, I'll write it in red here so that I know that this is my answer. The relationship is caps lock, and linear. All right, we can see that because the line angles upward. It's also a straight line. Does that make sense with what we think, right? So as we increase force, did we expect acceleration to increase? I think that makes sense, right? That kind of makes sense with what we've seen in the world. So yes, this relationship does make sense because look at Google Docs just giving me all the answers. It just stops it because it's not going to tell me why. Relationship makes sense because as force increases, acceleration should increase as well. Right? That makes sense to me. If we're pushing on something harder, it should accelerate faster. Okay. What is the slope of the line for your graphs? Now, I only made one, so I'm going to go up here. The slope is next to your X right here. So my slope is 150. So the slope of my line (150). My mass, if I go back and look at what my mass was also 150. So slope is equal to the mass. Right, we've just seen there that slope and mass are going to be equal, right? And you should find that for both of your graphs, right? If you're looking at both of the graphs, if you did them correctly, the slope of your graph should match the mass of your object or whatever you're pushing. Y-intercept, right? What is the y-intercept? So let's go back here. If we look at y-intercept, right? Y-intercept is the plus whatever that number at the end is here. Now, that looks like a funky number because it's actually in scientific notation. And I've said here, if it's a number with an E in it, it's 0, right? So if we look, 2.29 E negative 3 is actually, if I turn that into a real number, it would be 0.00229, right? Which is a really small number. It's pretty much 0. So if your number has an E in it, like mine does right here, it's pretty much 0. So the y-intercept, or my y-intercept here, let's change this to red again. And you should see the same thing in your graph. Approximately 0. Right, my y-intercept is approximately 0. So the last part here, the key to this, right, the end-all be-all for this little lab activity, using y equals mx plus b, which is slope-intercept form, right? Write the general equation that you have found for the relationship between force and acceleration. So we basically want to take y equals mx plus b and replace it with all of the things that we've found so far, or all the things that we've had, right? So y, right? What were we using for y? Well, our y axis was force. So I could replace y with force. If we look at x was acceleration. So I can replace x with acceleration. M is slope. We said slope was equal to mass. So I'm going to replace m, which is slope, with mass. Right? So I can replace slope with mass. And b, we said, is approximately 0. So b is going to be 0. If I replace all of that, right, y equals mx plus b, and I replace it, so what, instead of y, I'm going to have force equals, instead of slope, I'm going to have mass times, where's the times button? Times x, I'm going to write in acceleration, plus 0, right, because my b was 0. That's what we end up with. We end up with a relationship of force equals mass times acceleration, right? So, oops, Newton's, stop that. No, I don't want to write all acceleration, right? Newton's second law gives us a relationship between force, mass, and acceleration. What relationship do we end up with? We end up with force equals mass times acceleration. All right, so this is what I'm looking for at the end, right? We replace y with force, we replace slope with mass, we replace x with acceleration, we replace b with 0, right? Which is all things that we should have discovered from our graphs. And then we end up with our final equation, the relationship between force, mass, and acceleration. I'll highlight that in bright blue so we know it's important. Force equals mass times acceleration. All right. So that was a little walkthrough of the lab that you guys are doing today. Like I said, you can pretty much get all the answers that you need. The only thing that you really have to do by yourself is the second data table and the second graph. All right. I'm leaving that up to you guys. All right. I did one of them for you. You guys can do the second one. All right. So I will stop that there, right? Once you finish that, you can submit that for the Newton's second law PhET simulation lab. It has to be turned in by 11:59 tonight. If it's in by then, you will be considered attending class today, all right? As long as it's in before 11:59 tonight. All right. I'm going to stop this recording here. I hope you guys have a great weekend. I will see you on Tuesday. All right.